Hello, my name is Baris and this is my Physics 2 Lab 6 Magnetic Molasses Experiment. So first of all, the introduction. The purpose of this experiment was observe and quantify Faraday's law in action by a dropping magnet down an aluminium tube, and then creating a computational model for Faraday's law and compare results between the actual experiment and the computational model. And then our results was recorder time on average was 1.172 seconds and computational time was 0.468 seconds. The physics principles behind our experiment. First, it was Faraday's law. Changing magnetic fields causes EMFs in a conductor. Secondly, Biot-Savart law. Magnetic field is proportional to distance and magnetic moment. And then lastly, Lenz's law. Induced magnetic field due to a magnet in a conductor always flows to oppose the change in flux. And then on the right in a yellow box we have EMF formula, which is minus the change in the flux. Experimental procedure. Our system was magnet, the surroundings were tube and earth, and our assumptions, we said there is no air resistance, and bar magnet acts like a dipole, north and south pole. And on the right there is a picture of myself dropping a magnet into the aluminium tube. Calculations. We calculated the length of the tube as a 46.2 centimeter, which equal to 0.462 meter, and then the radius was 1.5 centimeters inside, which equals again 0.015 meter, and then 2 centimeter outside, which is again equal to 0.02 meter. And then average time based on our 5 trials is 1.172 seconds. Computational model. We use GlowScript for the computational model, and these two pictures are part of code from my GlowScript Lab 6 code. And then the results of the computational model. There is a velocity versus time graph, which we clearly see the differential decrease in velocity over time, and then the result was 0.468 seconds. Possible errors. Drop was imperfect, or tube was bent and not perfectly rounded. These two are possible errors. For the discussion part, the intensity of the coloring on the tube indicates the magnitude of current flowing through each ring. Red and blue indicates current flowing opposite directions. Which color corresponds to clockwise current as viewed from above, and which is counterclockwise? How can you know? What happens to the dynamics of the system when you flip the magnet around? How does the total time in tube of your real-world system compare that of your computational system? How might the computational system be made more accurate? What does the shape of the velocity versus time plot tell you about the forces acting on the bar magnet? Discussion. What if the resistivity of the conductor were reduced as close as possible to zero? How would the dynamics of the falling magnet change? What if holes or slots were cut into the tube? How would this affect the ring current in your model? Thank you for listening.